Hello everyone. So this topic is on the first portion from module 6. Okay, so we'll see. So in module 6, the topic is device drivers, which we are gonna learn in this video. Mainly, we have three topics coming in module 6. It's on device drivers, text editors, and debuggers. So let's learn about device drivers. In device driver, you have to learn the general design of device driver, what are character and block device drivers, and an anatomy of a device driver. Okay, these are the topics that we will be learning in this video. So let's start with the general design of a device driver. First of all, what is a device driver? Okay, so device driver, you might have heard of that word. Okay, right? So you can define it as a glue between the operating system and its IO devices. Okay, so device driver can be defined as a glue. So what does that mean? You have the operating system software and you have the IO devices which is attached to your system, right? So we can define this device driver as a glue, okay, like an interface between the operating system and the IO devices. So it can act as a translator. Okay, what does it translate or convert? It translates or converts generic request received from the operating system into commands that specific peripheral controller can understand. So what does it mean? You get a request from the user. So that request is given to the operating system initially. Operating system will accept this request and it will convert it into commands. Okay. Operating system which contains the device driver will convert it into commands which the specific IO peripheral device can understand. So mainly we'll see one example where the device driver can be built with C programming. So when it converts it into commands, mainly it will be of C programming commands. So these device drivers are basically part of the operating system kernel. Okay, so in operating system, you have many modules like process manager, memory manager, file manager. So along with that, you have this device driver manager also. So it is part of the OS kernel. So the drivers are nothing but software modules that are built separately and plugged into kernel when needed. These drivers. So by default, when you install the operating system, it will contain some device drivers which are needed for your keyboard device or your output device and so on. But suppose if you want to connect a printer to your system, you will have to install a driver separately, right? You might have done that part. If you want to connect a printer or a USB, sometimes you already have a USB port in your system, but sometimes if some ports are not identified or recognized, you might install device driver separately and you might download and install the device driver separately. So when you do that, it is plugged in into kernel according to your need. So that is a rough overview of what a device driver is. Now, if you look at the general design structure, you can see that here you have the software part coming and here you have the hardware part coming. So if you look at the structure here, you can see that you have the application software coming first, right? You have the application software. So from the application software, the request from the user is being read from the application software. So it will make necessary calls to the operating system. Okay, the application software will make necessary calls. Say for example, if the user wants to type something. Okay, so now you can see that I'm typing something in the screen, right? So if the user wants to type something on the screen, then that is a request. It's like a system call. So you have heard of system calls also. Some of the system calls like read, write, to manipulate the data between IO. You might have heard of the system calls read and write. So this is a system call which the application software will send to OS. Okay, so what does the OS do? So OS will analyze this request and it will send the request to the appropriate device driver. So here you can see that all these are the inbuilt device drivers that comes along with the operating system when you install it in your system. So for example, you have a device driver for your screen, you have a device driver for your keyboard. Now this design is a very old one. That's why it's mentioned that it's a floppy device driver. But nowadays floppy disks are being replaced with your optical disk drive, right? Or your CD drive. So you will have if your system supports a CD, or optical CD, it will have a CD drive, and it will have a hard disk device driver also. Yeah, you will have a hard disk device driver also. According to this design, they have told that OS has all these device drivers installed as a part of the OS kernel. So OS will analyze a request and it will send the request to the appropriate device driver. So for currently our request is you have to write something, right? So OS will analyze the request and send it to the maybe screen device driver, or maybe to the keyboard device driver, depending upon what action has to be performed. Now, what happens is the device driver will again analyze this request that is coming from the operating system. What does the operating system want? Okay, whether it wants to print something, whether it wants to read something. So depending upon that, what the device driver will do is it will issue commands. Okay, so these commands can be in the form of any language. So it will issue commands to the interface, hardware interface. So which interface it is? Is it the screen interface? Is it the keyboard? Or as for each of the device drivers, you will have an interface. So this interface acts like an intermediary between your devices and the software. Okay, the devices communicate to the software through your interfaces. So the commands is being issued to the interface, and to perform the required operation as needed by the OS. So what service is it requesting for? Based on that service, it is it will issue commands appropriately. So this is a general design structure of your device driver. So yeah, this arrow accidentally came when I took the screenshot of this image. Okay, so this arrow is not there as part of this image. You can just ignore that arrow. So the design that we saw in the previous diagram, it's been whatever I have explained is what is given in this slide. So initially it was mentioned that the application software will make system calls to the OS. Say for example, write a particular data to file X. So the operating system will analyze this request and it issues the request to device driver. So issues a request to device driver means to the appropriate device driver. Okay, so here you can say that it is a appropriate device driver. Which device driver it is, that the OS will find out. So I can add the word appropriate. Okay. So OS will analyze the request and issue the request to the appropriate device driver. So here you can see that the US application software said write a particular data to file X. So file X means internally the file will be stored as in disk, right? So it will analyze the request and it will say that in disk 2 and in block say 1, 2, 3, 4, there is where the value has to be written. Now again, device driver will analyze this mode and by issuing commands to the hardware interface to perform the operation needed to service this request. So it becomes even more specific. So you are writing something, right? So in order to write, you have to transfer some number of bytes. So that some number of bytes will be stored at some location, right? So from that location, you transfer the data to the disk 2. So this disk 2 is mentioned even more specifically as the block 1, 2, 3, 4, which is given here is mentioned, and which cylinder, which head, and in which sector. It's been given in a more specific manner. That's what the device driver will do. So that is all about the general design of device driver. Now let us look at what is the advantage of having a device driver. So the main and foremost advantage is it simplifies the working of the operating system. That is the main advantage. So without a device driver, operating system would be responsible for talking directly to the hardware, which adds extra overhead to the operating system, right? It will add, you'll need extra like hardware. Okay, so extra hardware support will be needed by the system in order to work this out if device driver is not present. So OS has to directly take up that responsibility. That is why a part of the OS, which is a device driver, does this role. So if device drivers are absent, then what will happen? Suppose if you want to add a new, if you want to add a support for a new device driver, okay, that if you have to modify the entire operating system. Then the next advantage as part of simplifying the working of operating system, you can say that the individual hardware request can be ignored. Since device driver is there, individual hardware request, that is to the IO device or to any peripheral device or to any USB device, it can be ignored, and OS can give the request, the generic request directly to the device drivers. So all it says is the OS can give all the request to the device driver directly. That is this point. OS doesn't have to bother about the individual hardware request. So the device driver takes device independent request from operating system and convert it into hardware request. That is, device driver can take up any type of request from the operating system. It is not dependent on any particular device. So it takes up any device independent request and it converts it into the required hardware request. So this is an advantage of device driver. Now, what are the major design issues related to device driver? So it mainly talks about three types of issues. The first one is the communication that happens between the operating system and driver. So you have to deal about the exchange of information. Information means mainly the commands and the data between the operating system and the driver. So how do they communicate? How do they exchange information with each other? That is one issue. And for this communication, what are the major support functions that the kernel will provide for the benefit of device driver for the communication between the operating system and driver? Now the next design issue is between driver and hardware communication, right? So you have the application software, then you have the operating system, then you have the hardware, and you have the device driver. Sorry. Here you have here you have the device driver, and here you have the hardware. So the first major design issue is the communication between operating system and the device driver. So how do they exchange information, and what are the various support functions provided by the kernel in order to benefit this operation communication? Now next is between the device driver and hardware. That is the next design issue. What is how does a device driver and hardware communicate? How do they exchange information? Information means commands and the data. So how do they exchange information is an issue, design issue, and how software talks to the hardware and how hardware talks to the software. Okay, so you have this is the entire software that you have, right? So this is a software part and this is the hardware part, and this is the hardware part. So how do they basically interact with each other? That's what that is another design issue which has to be handled by the system. Then the third issue that they have mentioned is the actual driver internal operations. Okay, what are the basic internal operations performed by driver? So what all operations can the driver perform? So some of the operations that they have mentioned, interpreting commands received from the operating system. So you have to understand what commands is coming from the operating system. That is one of the issue. Then how do you schedule multiple requests coming from multiple application softwares? Then how the data is being transferred across the interfaces between the operating system and hardware. So how the data is being transferred from OS to hardware and from hardware to OS. Then the next issue is accepting and processing the hardware interrupts. How the interrupts are handled. Then how the integrity of the drivers and the kernel's data structures is maintained. So the driver will have a set of kernel, will have a set of data structure, and the kernel will have a set of data structure. So how do you maintain the integrity of them both so that there is no overlapping of operations happening? So all these are the design issues which, pertaining to the driver internal operations. So these are the main design issues. Okay. Now let us look at the next topic. We learn about what are character and block device driver. So there are different types of device drivers. The main categories are block driver, character driver, terminal driver, and stream driver. So in this video, we will be learning only about block driver and character driver. So let's start with block driver. So block drivers is from the word itself, okay? From the word itself, block. What it means is it communicates with the operating system by exchanging a collection of fixed sized buffers, or it is called as block. So a single block of data or a group of blocks of data are being transferred between the operating system and the driver using block drivers. So how this block of data or fixed size buffers are being transmitted is with the help of cache. Okay, with the help of cache. That is, OS manages a cache of these buffers and it attempts to satisfy user request for data by accessing the buffers in the cache. So I'll show you the diagram first. So here you can see this is a user process part and this is a kernel part. So user process will issue a read or write system call to the kernel. So here you can see that driver is separated from the initial part. Driver doesn't come into role in the initial part. So OS will have some call system handler. Okay, the system call handler will be there, and you have something called as buffer management routines also. So when you get a read or write process request from a user process, that request will be transferred to your system call handler, which in turn transfers it to, you have various buffer management routines. So what this buffer management routines will do is it will search. So this is a cache. Okay. So you have some buffer cache headers and the data. It will search the buffer cache for the requested data. If the requested data is present, it will be directly sent back to the user process. Only in the absence of the data in the buffer, the request will be sent to the driver. So the driver will go to the required memory and it will fetch the required data, and the data will be given back to your user process. At the same time, the data will be added to your cache as well. So this acts like a cache memory. You are familiar with the concept of cache memory, right? When processor requests for some data, it is first checked in the cache memory. Only if the data is absent, the data is fetched from a higher level of memory. So the same concept is applied here as well in block drivers. So let us look at these points given here once again. So OS manages a cache of these buffers and attempt to satisfy user request by accessing the buffers in the cache. So the driver is invoked only when the requested data is not present in cache. Or when can the driver be invoked? In another possible option is, suppose if the buffers in the cache have been changed. That is, the data in the cache has been changed and it has been written out. In such case also, the driver will be invoked for getting the suitable data. And this device driver handles requests from the OS to fill or empty fixed sized buffers. So either you will have to fill the buffer or remove everything from buffer so that you can fill the next data. So only in such case, the drivers will handle the request. So this is about block drivers. Block driver is used to transfer a collection of fixed sized buffers, and it is done through the cache buffer. And the driver is invoked only when the requested data is not present in the cache. So an example for a block driver is devices like hard disk. Okay, so you have your hard disk or your external USB devices that is connected to the system. In such cases, you are transferring a block of data from your device to the system. So block drivers can be used for such a scenario. So that is about block drivers. Next, character drivers. So in contrast to block driver, here character driver can handle requests of arbitrary size. It need not be fixed. That is the main difference from block driver. Character drivers can handle any sized request. And it will support any type of devices also. So this will deal, for data, like these drivers are used when you want to transfer data, which is a single byte. You can transfer a single byte of data at a time, or you can even transfer small chunks or small blocks. Okay, like block is a fixed sized. So anything smaller than a block or anything larger than a block can be transferred using character drivers. So example, you have your printers and all your serial ports and etc. You are trying to maybe transfer, you're trying to print a single character or maybe a block of data which is more than your fixed sized buffer. So in such cases, character drivers are used. So here what happens is there is no buffer cache. The request is sent directly to the driver, and the driver is responsible for transferring the data back to the user. Say, let us look at the diagram. Here you can see from the user process, you have the read or write system calls. So you have the read or write system call handler inside the kernel. The request is directly sent to the driver. The driver will have entry points, which we'll see. What is an entry point? I'll show you in the next slide. So with that routines, the driver will fetch the required data, send it back to the handler, which in turn will send the result back to the user process. So here the communication happens directly. Driver directly responds to the user request. So that is this point. The request is passed directly to the driver, and the driver is responsible for transferring the data directly to and from the user process memory. So if you would want to differentiate between a block and character driver, you can list out these points. So whatever points we have seen, okay, in block driver, it transfers data to and from the kernel's buffer cache. Whereas in character driver, it transfers the data directly to and from the user's process. Then block driver is not suitable for devices that perform variable sized blocks. But whereas in character driver, it is ideally suited for such type of transfers, for transferring variably sized data blocks. Then in block driver, mainly it is used to support a device that contains a Unix file system. So any operating system file system, mainly you store it in a hard disk, right? So such type of devices, block drivers supports. Whereas character driver doesn't support such a file system. So if it is a character device, then the file system cannot be mounted if you are using character driver. Block driver is suitable for mounting a file system. So as mentioned before, it is ideally suited to support disk drives, hard disks, etc. Whereas in character driver, it is suited for printer, serial ports, parallel ports, keyboard, and other IO devices. So that is differentiating block and character driver. Now the last topic we have, what is the anatomy of a device driver? So anatomy means structure, right? What is the general structure? So as I have mentioned before, this Unix device driver is nothing but a collection of functions which can be written in C language. And these functions are called by operating system using the standard function calling mechanism. So you are familiar with C programming, right? So just like how you call functions in C program, here the device drivers is also called in a similar way. Now these routines that we have, the functions that we have, you call it as entry points. So you have to call a set of functions in order to process a request. Okay, say for example, if you are reading something from memory or you're writing something to memory, OS will send the request to device driver. So device driver will issue a set of commands to process this request. So those commands are written in C programming language. So in order to process that request, the commands will be written in routines. And these routines, you can call it as entry points. What is an entry point? From the word itself, it says that is an entry point to your actual set of commands. So this driver is a set of entry points, or it's also called as routines, that is called by the operating system. Okay, so driver will contain a set of routines that is called by the operating system. So apart from this entry points, the driver can also contain data structure which is private to the driver, and it can contain references to kernel data structure external to the drivers, and it can contain routines which is private to the driver. So routines which is private to the driver are not entry points. Okay. You have entry points. These entry points are called by the operating system. So you can compare this you can have a comparison with a C programming file. So what is the entry point to a C program that you write? You have the main function, right? main function. So you know that is a entry point. That is a entry point to your C program. So you do not call this main anywhere, right? Do you call main anywhere? No. You might have learned that main is automatically called by the operating system. And apart from main, the program can even have user-defined functions, right? Say, for example, add something. Any user-defined functions the program can have. So you can compare it. This device driver also can be compared in this way. That is, it will have an entry point, okay, which will be called by the operating system. And apart from that, it can also contain private data structures, and it can contain references to other kernel data structures, and it can contain routines which is private to driver. So these routines are not entry points. They have to be called separately. So mostly these drivers are written as a single source file. So every device driver will be, say for example, a device driver for hard disk will be written as a single source file. So they are saying mostly. In some cases, we can have more than one file which acts as a a program, which acts as a set of programs governed with a single device driver. Now, the initial part of the driver is sometimes called a prologue. Okay, so what is this prologue? We'll see in the next slide. So prologue is everything before, prologue is everything before the first routine. Okay, so whatever you have in the first entry point, before that, whatever you write before the first entry point, that you call it as a prologue. Now, this is also similar to your C program. That is, before the main function that you have the statements that includes the directives, right? You have the hash include directive statements. So if it is referencing any header files from any other external kernel data structure, you will have hash include directive coming. Like where hash include, you are using it for including the header file that contains printf and scanf. You remember that? So similarly, if your device driver refers any external kernel data structure, it will that will be included in the hash include directive. And similarly, you might have learned about hash define also. So that's mainly used to provide mnemonic names for the various constants used in the driver. So in particular, constants related to location or definition of registers, for that you can use hash define. Now, even like before main, you can have declaration of variables, which you call it as global variables, and data structures, like structures can be defined before main, right? So this entire part is called as a prologue. So whatever comes before your first routine. Now the remaining part of the driver are the entry points. So remaining part of the driver is a entry point, and the C entry point is a C function only, which is referred by the operating system, and then the routines which are private to the driver. So you can compare this entire structure similar to your C program. You have a directive initialization coming, followed by your main program, which is the entry point, followed by the user defined routines, which is private to the driver. So that's about the anatomy of a device driver. Now that is the end of this video lecture on device driver. So you have mainly learned about what is the general design of device driver and what are character and block device drivers, differentiating both of them, and finally the anatomy of a device driver. So I hope you understood the topics. Thank you so much for watching.